This is our topic of discussion today, that is application of calculus in commerce and economics. We will deal with the commercial scenario. Okay, we'll deal with the commercial scenario now, where, as you know, everything is centered around what? Around the manufacture and sale of goods, isn't it, or sale of items. So basically, when you are setting up a unit for manufacture and for sale of certain items, certain product, then what do you need? You need a lot of expenditure. A lot of expenditure is involved, isn't it, in setting up that unit. So that expenditure or the cost that is involved is dependent on the number of units that you are manufacturing, right? So therefore that becomes a function, and in fact it is a function of the number of units, which is represented by, suppose, x. So we have something, the first term that we have under this, we are going to see how calculus is going to be applied in the commercial scenario. And under this, the first term that is involved is the cost function, which is nothing but the expenditure involved in setting up a manufacturing unit. It is denoted by Cx because it is a function of x, where x is the number of units, and therefore this is given by the sum of two things. What is it? Let's see that. I have written what? Vx plus f. What is Vx? Vx is your variable cost, and f is your fixed cost. Okay, so as you can see, notice something. I've written simply f over here. I've not written f of x, whereas here I've written v of x. Vx doesn't mean v into x, it means v, which is a function of x. Why is it a function of x? Because it is a variable cost. Variable in the sense because it depends on the number of units that you are going to manufacture and sell in the market. Okay, so basically what we have here is, now what is coming under variable cost and what is coming under fixed cost? Or that which is dependent on the number of units will come under variable cost, and fixed cost means that will always be there irrespective of whether you manufacture any unit or not. Even if the manufacturing unit is closed for some time, you have to bear this expenditure, right? For example, there will be some amount of electricity expenditure, rent is a kind of fixed cost, because even if, especially if it is not your own establishment, you will have to pay a certain amount of rent, which is a recurring cost. Okay, and so fixed cost is also termed as recurring cost. Okay, it is the recurring cost because it keeps recurring, and in fact it exists even when x is equal to 0. That means even when there is no output, or when there is no number of units being manufactured, then also you have to bear this cost. And variable cost, as I said, it depends on number of units. Depends on number of units x. Okay. If the the load of manufacture is more, number of units being manufactured is more, then the number of laborers will be more. You will need more space, isn't it? So all these factors, the number of laborers and the expenses of their salary and all that will come under variable cost. It can come it will come under variable cost because it depends on the more number of units means more laborers, less number of units means less laborers, and also provided the time is fixed, isn't it? If the time is fixed, then of course then the number of laborers will depend on number of units. So this is your cost function, which is variable cost plus fixed cost, or the recurring cost, and also termed as overhead cost. Also in some questions you will see they are saying overhead cost. Okay, so this is also termed as overhead cost. Okay, now once you have manufactured, you will sell it in the market, isn't it? And once you sell it, what is the purpose of selling it? So that you earn something. We call it revenue. Okay, so the earning or the revenue is also dependent on the number of units that you are going to manufacture and sell in the market. So it is also a function of X, and it is called revenue function. Revenue function Rx. Revenue function Rx, which is given by P into X, or simply Px into X. Now what is this? What is P? X you know is number of units. What is P? Where in the first case P implies the selling price of each unit that you are manufacturing and selling in the market. And in the second case, Px, this is a function of X. It has a special name. It is called demand function for the product. Now those who have economics will know it better. That is, what is demand function? Of course, it is a function which is dependent on the number of units that is in demand in the market, because this is a constraint that you have to put while you set up your manufacturing unit, because if you manufacture more number of units than what is in demand, obviously those units won't be sold. That will be a loss. That will be a wastage, isn't it? So therefore, you have to take into account what is the demand, what is the market demand, and accordingly, you have to set up the demand function, and accordingly, you have to decide how many units you have to manufacture and sell, and or rather, what would be the price of each unit, so that your company or whatever you are setting up does not suffer any loss. In fact, your target is to earn profit, because if you don't earn profit, what is the use of setting up a business, isn't it? So that is what I've written, where P implies that what is given in the question, it depends on that. If selling price of each unit is given, then you will use the first expression to find the revenue or the revenue function. If the demand function is given directly, then obviously you will use the second expression. You will substitute the function on the demand function for the item, okay, and demand function of the item for each unit, and therefore this will give you your revenue, each unit that you are manufacturing and selling in the market. Now once you have borne the expenses of setting up your business, after that comes you are selling it in the market, and then you will calculate how much is in your pocket, how much has gone into your pocket, isn't it? That is, what is your profit? That will be your main target. So therefore, we have the net earning, which is your profit. Okay. This also depends on the number of units you are manufacturing and selling. In fact, it is the profit function. It is a function of X, and it is given by obviously the amount of earning that you are getting minus the amount of expenditure that you have borne. So therefore it's Rx minus Cx. So it is obvious, it will be the revenue minus the cost that you have incurred. Okay. Now out of these, you can find out the average, what will be the average cost for the items that you are manufacturing, what will be the average revenue that you are going to earn. You'll get a fair idea of that, and you can also get an average idea of the variable cost function as well. Okay, and what are they going to be? We can get an idea of the average cost function. Average means what? Total by number of units, isn't it? When you do average in general, what do you do? Sum of the quantities by number of quantities, isn't it? Sum of the values by number of observations. So here also same thing. So it's going to be the total cost that is involved by the number of units that you are going to manufacture and sell. In other words, you can write in short, that is AC is equal to Cx by X. This is your average cost function. We also have average variable cost function, which will obviously be what? Variable cost that is involved by the number of units. And so we have ABC is equal to Vx by x. Okay, ABC is going to be Vx by x. And also from the revenue function, you get an idea of the average revenue that you are going to earn. Average revenue function, it will be the total revenue that you are earning per unit. Okay, that is number of units being manufactured or sold. In other words, average revenue is equal to Rx by x. Okay. Next we move on to a special term which is called break even point. This calculation is a must before you set up any manufacturing unit. Okay, calculation of break even point. What is break even point? It is the, I'll write the definition first. It is the number of units. Can you see? Yes. It is the number of, how far? Till here. Okay. Number of units. It's number of units. Okay. That have to be manufactured. That have to be manufactured and sold, so that there is no loss, even if there is no profit. Okay, there is no loss even if there is no profit. When will the situation arise? Obviously, when you're spending an amount of money to set up the unit. Okay, so you must not suffer any loss. That means at least the amount that you are spending you should recover, otherwise you will be in losses, isn't it? So that is the least that you can expect, so that you don't go, so that you don't suffer any loss. So therefore it is such that expenditure involved, expenditure, T-U-R-E, expenditure that is involved should be recovered or is recovered from the earning that you make. So it is the minimum number of units that have to be manufactured so that the expenditure involved is recovered from the earning. And that means basically you have to find the value x, because what? It is number of units for which, can you see? Yes, for which the earning is equal to expenditure. You find x for which Rx is equal to Cx. In fact, there is an alternative way of writing it also. So if Rx is equal to Cx, what will happen? Remember that expression, Px, profit function. Profit function is what? Rx minus Cx. So therefore, it means that Rx minus Cx will be 0. In other words, the profit function has to be 0. You can solve this equation also. Either if the profit function is given, then you will solve it directly, that you will equate it to 0. And that is, you will take profit function is equal to 0 and you will find out the value of x. That will give you the break-even point. And if revenue and cost function are given, then obviously you will equate the revenue function and the cost function. So either this equation or this equation, depending on what is given, you have to solve to get the break-even point, that is the value of x, for which there is no loss even if there is no profit. Okay, so, and that will happen when expenditure involved is the same as the earning. That is, you recover whatever expenditure you have borne for the setting up of the unit, and then that will be the break-even point. Next we have the terms like marginal cost, MC, okay, and we also have marginal revenue. Now what are they? Basically they are nothing but, this is nothing but rate of change of cost per unit change, rate of change of cost per unit change in production units. Okay, what is the situation over here? That is, suppose today you know that in the market you need 10 items. I took a small number. You need 10 items, okay, to be released in the market. But then some months later, by the time you finish your production, you complete your production and you want to set it out in the market, you come to know that you need some extra units. You need 5 more units to be manufactured and distributed in the market. So for each of these extra units that you have to manufacture, what will be the cost that will be involved? What cost will you have to keep aside? Okay, so that demand is fulfilled. Okay, that will be given by marginal cost. And rate, as you know, rate means what? Rate of change of quantities. dy dx is what? Rate of change of y with respect to x. So similarly here, production units over here is your x, and rate of change of cost. Cost means cost function, so therefore it is derivative of the cost function. That is, dc dx will give you the marginal cost that is involved. You can write it separately. That is, MC is equal to dc dx, where C implies nothing but the cost function Cx. I wrote in short C, that's all. Similarly, you have something called marginal revenue. Marginal revenue, MR. What is it? It is rate of change of your earning, how your earning will change, of revenue per unit change in production. Okay, per unit change in production. So this will therefore be given by rate of change of revenue, that is dr dx. In other words, MR is dr dx, where R implies the revenue function Rx. Okay, so this is what we have. And notice something, suppose marginal cost is given. Now this is obtained from differentiation of cost function, isn't it? So you know, integration is the reverse of differentiation. So when marginal cost is given, you can find out the cost function. How? Suppose you don't know the cost function, but the marginal cost is given. So how will you get the cost function in that case? So in that case, that means from here you want this. So therefore, what will be involved? Integration will be involved. When we do the numericals, you will see. So to get marginal cost, you are doing differentiation of cost function. Okay, and from the marginal cost, when you want to get the cost function, you have to integrate. Okay, when you differentiate the revenue function, you get the marginal revenue. So when you integrate the marginal revenue, you will get the revenue function itself. So that comes from the concept of integration as reverse of differentiation. So this is what we have, and therefore let us apply this to numericals now. Okay, that is the first example. The question says that demand function the demand function for a monopolist. Monopolist means he's the only person in this business. That is why he's a monopolist. Okay, whatever the business is, we are not concerned with that. So demand function for a monopolist is given by is given by x is equal to 100 minus 4p. Find subpart 1 total revenue function, subpart 2 average revenue function, and subpart 3 price and quantity at which MR is equal to 0. Find the total revenue function, the average revenue function, and the price and quantity for which MR is what? Marginal revenue is equal to 0. Okay. Excuse me. The first subpart. What is revenue function? Revenue function, according to definition, it is Rx is equal to demand function is given. Okay, Px into X. Okay, so we will make P as the subject. This has to be a function of X. So we will make P as the subject in terms of X and we will substitute. So in the rough work column, you are writing what is the demand function. Because here it is given as x is equal to, it should have been given as p is equal to. X is equal to 100 minus 4p. This means 4p is equal to 100 minus x. So p is equal to 100 minus x by 4, which can also be written as 100 by 4 is your 25 minus x by 4. This way also you can write. Okay, so this is your demand function. So we will replace it over here. 25 minus x by 4 into x. In other words, the revenue function Rx is given by 25x minus x squared by 4. This is your answer. It has to be an expression in x. The next subpart now, the average revenue. What will it be? Subpart 2, average revenue function. Average revenue function is given by, we discussed a little while ago, Rx by x. That means you will divide 25x minus x squared by 4 divided by x. You will know I wrote into 1 by x in front. It's the same thing, just to make it look good. So therefore, term by term, if I do 1 by x into 25x, x cancels, so that's 25 minus x and x square cancels, so that makes x by 4. So this is your average revenue function. This is your answer. Right? Next comes find the price and quantity at which MR is equal to 0. Now they are already setting up a condition that by question MR is equal to 0. This is given. MR is what? MR is your dr dx by definition of marginal revenue. Okay. What is R? R is this. So that means we have to do, can you see? Yes. You have to do ddx of this function, that is 25x minus x squared by 4 on the left and equate it to 0 because this is your revenue function. I suppose you know how to differentiate. ddx of, it will get distributed. ddx of 25x will be simply 25 minus 1 by 4 as it is. ddx of x squared will be your 2x and that has to be equal to 0. In other words, 25 minus x by 2 because 2 and 4 will cancel. This is your 0. So what is the value of x? 50, isn't it? So this means x by 2 is your 25. Can you see? Yes, you can see how far. Okay, so therefore x is equal to 50. 50 is what? 50 units. So you will mention over here, that is number of units is equal to 50 units. Okay, this will be your answer. Next comes the quantity. The price. This is your quantity. So it's overlapping over here. Sorry, I think you write it separate. Which means number of units is equal to 50 units. So this is the quantity that they are asking for. Now the price. Price means what? Demand function itself is the price, isn't it? Because we have replaced that over here. We know that already. We have discussed that. So what is the corresponding price? That means we have to substitute over here. This expression, since I have written the expression over here, I am filling it up over here. Continuation of subpart 3. Corresponding price will be given by for MR is equal to 0, that is for X is equal to 50. What is the corresponding price for which MR is equal to 0? And MR is equal to 0 means X is equal to 50. How will we get that? That will be given by, I'll draw a line here so that it doesn't overlap. This implies, where is my P? P is over here. So it will be 25 minus X by 4, isn't it? So it's 25 minus 50 by 4. I'll write it as P is equal to, that is P is equal to 25 minus 50 by 4. I'll put this as equation 1 and I will write it as from equation 1. Okay. So what is the value therefore? 50 by 4, isn't it? Because 25 by minus, this is your, shall I write the answer directly? Do I have to show the working? I think I'll write it. This implies P is equal to 50 by 4. 50 by 4 is how much? That is 12.550. Don't forget to write the unit. It's price, so it will be rupees. 12.50. So this is the corresponding price per unit for which MR is equal to 0. That is, when number of units is 50, the corresponding price is this. Okay. So that was an example. We'll move on to another example now. Okay. So the second example. This is the next example. The question says, if C is equal to, C is the cost function obviously, AX square plus BX plus C. Okay, if C is equal to AX square plus BX plus C, obviously ABC are constants, represents the total cost function. Then find, there shouldn't be a full stop there, find number 1, the slope of the average cost curve, and number 2, the slope of the marginal cost curve. Now, what is the average cost curve and marginal cost curve? Actually, those who have economics will be knowing it better. That is, every function can be represented by a curve, isn't it? So the curve that is drawn for the average cost function, that will obviously be termed for different values of x. You will get different values of the average cost, isn't it? So average cost is what? Cx by x. Okay. So for each value of x that you are taking, you will get a certain value for Cx by x. If you plot that, you will get a curve, and there is a significance of the curves also, which I am not discussing here because that is not our that is not our sphere of discussion, because we are mainly concerned with applications of the things that are there, the terms that are there. So all those details you will get with reference to any economics book or any, in fact most of you will be knowing it. especially the ones who are in the arts and commerce section. So I'm not going into detailed discussion about the slopes of the curves and their nature and their significance and all that. We just have to find out the slope. As such, we can do it mathematically also. Because remember, slope of a curve is given by what? If you remember, y is equal to fx, significance of derivative when we did. Yes, y is equal to fx is a function. The slope of this function or the slope of the curve representing this function will be given by d dx of y, dy dx. Remember, dy dx is equal to tan psi, that expression. Yes, I think you remember geometrical interpretation of derivative. Dy dx is equal to tan psi was the expression which gave us the geometrical interpretation of the derivative, geometrical significance. What was it? It was the slope of the tangent to the curve. I'll draw a rough sketch to help you recall what we discussed. This is the curve, suppose y is equal to fx, and this is a point P. Suppose the tangent at P, if we draw, yes, it makes an angle of psi, suppose. It makes an angle psi over here with the positive x-axis. Okay, the tangent at the point P over here makes an angle, which is at PT, the tangent, makes an angle of psi with the positive x-axis. Then, according to the geometrical interpretation of derivative, what did we have? Dy dx is equal to tan psi. That is, it gave us this is the curve, y is equal to fx. This gave us the slope of the tangent to the curve at the point P. So here also, in fact, when y is equal to fx, the slope is given by derivative of y. So here, when average cost is known, the slope of the average cost function will be given by d dx of the average cost that we will get. Similarly, d dx of the marginal cost will give us the slope of the marginal cost curve. If you have forgotten, then please write it over here, that recall the fact that dy dx at the point P represents slope of the curve representing y is equal to, or representing the function y is equal to fx at the point P. For those of you who have forgotten, you can refer and see. Okay, this is for reference only. So, recall the fact that dy dx gives us the slope of the tangent, slope of the curve representing the function at the point P, slope of the tangent to the function. Whatever, it's the same thing. So, therefore, what will we do now? We need to find out the average cost function, and then we will do d dx of the average cost function. Okay, so for the first subpart, we are finding out average cost first. Average cost AC. It is supposed to be Cx by x. That means it is ax squared plus bx plus c by x. How will we divide? It's a monomial in the denominator. So term by term division. Ax squared by x plus bx by x plus c by x. That gives us ax plus b plus c by x. This is our average cost function. So slope of AC will mean d dx of the function AC. And therefore it will mean we have to do d dx of ax plus b plus c by x. So d dx of ax means what? Simply a. d dx of b is your 0, and d dx of cx means c into d dx of 1 by x. If you remember the formula, it is going to be d dx of 1 by x is what? Minus 1 by x squared, isn't it? So d dx of that if we apply, so this is your slope of AC curve, and this is your first answer. For the second subpart 2, let us find out what is the marginal cost. Marginal cost MC. It it is ddx of c. Okay, so therefore MC is equal to ddx of what is the cost function? ax squared plus bx plus c. So therefore, can I write that side? Yes, it is a is constant, ddx of x squared is 2x, and b is constant, ddx of x is 1, ddx of c will be 0. In other words, we have MC as 2ax plus b. So what will be the slope of the MC curve? It will simply be ddx of the function MC, and therefore it is ddx of 2ax plus b, which is therefore ddx of 2ax will be simply 2a into ddx of x, that is 1, and ddx of b is 0. So therefore this is your this one we got slope of MC. In fact, notice slope of the MC curve is always constant, isn't it? In this case, slope of the MC curve is constant. It didn't ask for it. It didn't ask you to show that it is constant, but this is your observation. You can write it if you want. Okay. This is the next example. Fixed cost of a new product is rupees 18,000. I hope you can read. Fixed cost of a new product is rupees 18,000. Variable cost per unit is rupees 550. That means for each unit that you manufacture, the variable cost is 550. So if it is X units that you are manufacturing, it will be 550X. If demand function is Px is equal to 4000 minus 150x, find the break-even values. That means you have to find the number of units for which profit function Px is equal to 0, or for which Rx is equal to Cx. Revenue function is equal to cost function. So you will write let x be the number of units manufactured. Okay. First, let us frame the cost function. Here, what is given? Fixed cost is given as 18,000, and variable cost over here is how much? 550x. Because they are saying per unit it is 550. So for x units, it will be 550x. Therefore, what is the cost function? Cost function Cx is Vx plus f. So it's 550x plus 18,000. This is your cost function. We can easily frame the revenue function also, isn't it? What is the revenue function? Revenue function Rx is equal to demand function is given Px into x, and therefore it is going, it's Px into x. So what is Px? Let's substitute. Px is, I'll write below again, Rx is equal to, this is your Px, so it's 4000 minus 150x. This is to be multiplied with x. Okay. So what do we have? We have 4000x minus 150x squared. And this is your Rx. So this is your revenue function given by 4000x minus 150x squared. Now we will calculate the break-even values. What is the condition? You will mention for break-even point or for break-even values. What is the condition? Rx should be equal to Cx. This means now you equate 4000x minus 150x squared is equal to 550x plus 18,000. Just putting these in the respective places. Okay. So what do you get? You get a quadratic, isn't it? How much is it coming to? Okay. Each of these terms, I think we can divide by 50, isn't it? 4000, 150, 550. 18,000. All of these are divisible by 50 straight away. So that makes this as 80x. This becomes 3x squared. This becomes 11. And this becomes 360. What have I done? I have divided 12 by 50. Okay, you can check and see. So rearranging, what do I have? Basically, I have 80x minus 11x. That makes 69x is your 3x squared plus 360. We can divide further with 3. So that gives us 23x is equal to x squared plus 120. So what do you have? You have a quadratic x squared minus 23x plus 120 is equal to 0. Middle term factorization can be done, isn't it? Yes, 120, I suppose you know how to do middle term factorization. What will be the factors? 15 and 8, isn't it? So it's x squared minus 15x minus 8x plus 120, which is 0. From here you get x minus 15 minus 8 into x minus 15. So that, can I write that side? Yes, I can. So it's becoming x minus 15 and x minus 8, which is 0. So x is either 8 or 15. That is, conclusion will be that break-even values are 8 units or 15 units. That means at least 8 units have to be manufactured so that there is no loss even if there is no profit, or 15 units have to be manufactured so that there is no loss even if there is no profit. So this is how we find the break-even values. Here I didn't do PX because as it is I have RX and CX in front of me. So I just applied Rx is equal to Cx. If profit function had been given directly, I would equate profit function to 0, and from there I would get the values of x. Okay.